Ian.
So we've seen each other before.
Yeah, you look familiar.
Yeah. So lean manufacturing, to my knowledge, was developed by companies like Toyota after they observed Henry Ford's manufacturing plants.
All right, so Toyota, Ford, those are some keywords about lean manufacturing.
And the big idea was that they would order components just in time before they would actually manufacture it. So
Just in time. Anybody else? It was Ian, right? Ian, Lily, Ben, Dionis. What's your name? David. Reduce time energy. When you say reduce wasted energy, you don't mean like save electricity, like be green?
No.
Not necessarily. I mean, that could be part of it, but that's not what you were talking about. You meant like physical energy, like mental energy. Yeah. Okay, so anybody else have something to say about lean? Yeah. So increase what's profit again, somebody? Yeah. Something minus cost equals something minus cost equals profit? Yeah. Value. That was basically the entire point of the last hour we spent together, right? Value minus cost equals profit. Now, what's even cooler than value minus cost equals profit? Profit rate, the speed at which we can make money. If you actually take the derivative of that, you get like the acceleration of money. That's cool. The velocity of money is cool, right? Some people call that cash flow. How quickly is the money coming in? Is it coming in faster than it's going out? That's important. Okay, so value minus cost is profit. Value minus cost over time, profit rate. Lean manufacturing, because we want to increase profit or profit rate at our companies, right? That's a good thing. Okay. What else do we know about lean manufacturing? Yeah, Sri. Feedback based. What else do we know about lean manufacturing? We do have 5 S's. S's. The plural of S's. Who thinks the 5S thing is kind of weird? Why do you think the 5S thing is kind of weird? Because you know companies have 6 S's now? Because they added safety. Which, should probably have not been overlooked. The 6th S tends to be safety. What did you think is weird about the 5 S's? Well, okay. But a wise man once said that common sense is not very common. Right? So, and that was actually my first reaction when I was introduced to this whole concept of lean manufacturing. I was sitting in a seminar. I was actually in one of the Odiums. When I first really started thinking about lean manufacturing, I was in this seminar series. And they'd bring in these high-priced consultants to talk to us about lean manufacturing and teach us what it was. And there was people from all over the local industry that would come into this thing. It was like 150 people at each thing. We did it for 5 weeks. And I kept thinking, but of course, right? Of course, that makes sense. But what I realized about it was that it's not just the individual items that make up lean manufacturing are common sense or they make sense, that lots of people could figure it out. It's that they put it together and they organized it into a system. And some people have a systematic approach for how to apply it. So I think that's so lean manufacturing in general is kind of weird because it's all common sense. The 5S's in particular. So you know what we base our lean manufacturing on primarily? So Womack coined the term lean manufacturing in his book Lean Thinking. And he wrote that book after studying the Toyota production system. And so a lot of the lean words that we use come from the Japanese. So we have words like pokeyoke. Anybody speak Japanese, by the way? You do? So you're going to fix my mispronunciations, or are you just going to laugh? Usually nobody raises their hand, and I can say the words however I want to. But we've got things like pokeyoke and muda and things like that, and we use these Japanese words to talk about our lean stuff. But in the 5S's, we don't use the Japanese words. We managed to come up with 5 English words that started with S also. I just think that's kind of weird. Because there are 5 Japanese words that start with S. And we've translated them into English, and somehow it worked out. I just thought that was weird about the 5S's. What are the 5S's? Evan. Sort. What do you got? Straighten. Sort, straighten. I don't write as fast as you talk. Shine. Anybody know what the Japanese words were? No? Not even our sole... Were there 2 hands for Japanese speakers? Just one. Okay. Our sole Japanese speaker doesn't know what those words are either. 1, 2, 3, 4, and then safety, right? That's our 6. Oh, people get upset if you leave off safety these days. What do we mean when we say sort? If we're gonna, so let's say we want to apply our 5S's to our workspace. If we're sorting, what's your name? Josh. What do we mean when we say sort? So that's exactly it. We want to know what we have. And if we don't organize it in some manner, we'll just never know what's there. And so if you're applying 5S to a workspace, the first thing you want to do is figure out what it is you have. So that's why we sort it. Straighten. What do we mean when we say straighten? It's not make everything aligned, right? It's not take all the ducks and line them up. Make everything convenient to get to. Yeah, I like that. So it's put it, so we sort. Now, as we're sorting, if we find a lot of stuff that we don't use in that work area, what do we do with it? Give it, Evan. We remove it. And one of the tools that we might use to do that is we might put it in a little, you might have a box that says, this is the crap we're going to throw away if nobody tells us we're going to use it. Because it's not always the person who does the majority of the work in that work area that's doing the lean organization. And maybe there's multiple users of a work area. So you make a little box and you say, we're throwing this junk away. And you put it over here in the corner and you put the thing that you think doesn't get used in that box. If someone takes it out of the box and says, hey, no, we use this, then you know. Right? So that's a tool. But we want to eliminate any excess stuff that we're not using in that work area. That's part of sorting. Straighten means we want to put it someplace, and it's funny. Has anybody ever renovated a kitchen? You have? Did you use lean principles when you did it? No, was it before you started your OIE major? Yeah, okay. So I lived alone in an apartment. It's a pretty small kitchen. I renovated the kitchen. You could tell that the kitchen was designed by a manufacturing engineer when I was done. It was possible to load and unload the dishwasher without moving your feet. Everything that you needed to wash dishes, you could have without moving your feet. You got to do that by spacing the dishwasher far enough away from the sink so that you can stand between the sink and the dishwasher and have all the cabinets that all those dishes go in within reach. Load and unload the dishwasher. Now, there's other things about the kitchen. Once I got married, we lived in that house for about 4 years after we got married. It was also clear that it was designed for one operator. So So you got to think about how many operators are in the space when you're designing the space. But this straighten is about put the stuff where you can reach it. Shine. What's shine? Everybody look out. You're going to get by the glare. What's shine? Josh, right? Josh. Yeah, it gets back to partly to the sort part of it. Let's get rid of the stuff we don't need here. So keep it clean. When you're done using a tool, wipe it off before you put it away. Don't just put it away dirty. Clean it before you put it away so that it'll work again next time. If you, especially these tools, we use a water-based water oil emulsion coolant in our machining centers over here. And so there's water in it. If the concentration isn't perfect, it'll rust the metal tools. You wipe them off before you put them away so they don't get all rusty. It's keep it clean. Don't leave. One of the things that you're going to learn in lab is that we set the tool in the work offsets, right? Have you guys talked about that at all yet? We're going to talk about it a lot next week. But one of the methods for setting tool offsets in a machine tool, so when you set the tool offset, you're basically telling the machine how long the tool is. So one of the methods for doing that is to jog the tool slowly towards the workpiece. Take a piece of paper and wiggle it underneath the tool. And when you feel the tool touch the workpiece, because you'll feel it, you know that your paper thickness away from the workpiece. And so you can use that information to tell the machine where the tool is. Don't ever do that in our facility. Ever. There's lots of good reasons not to do that. One of them is if you're jogging towards the workpiece and you click too many, it breaks the tool. Every time. No exceptions, the tool breaks. The other reason, though, is that when people do that, they don't take a whole piece of paper. They go tear the corner off of a piece of paper. Because they don't want to waste a whole piece of paper. They get over there to the machine, they're jogging, they're doing this. Okay, I got this one. And then they need to do another one, and they get another piece of paper. Then they get another piece of paper. Then they get another piece of paper. And then, they need to write a note, and then this is stuck on the side of the machine, and there's a note written on it. And there's pieces of paper all over the floor. So if you leave pieces of paper over the floor, somebody could trip. We actually had an incident several years ago in the machine shop in Higgins, or it was I think it was in the MQP work area adjacent to the machine shop in Higgins, where some people had been working on paper. They didn't like their answers, working on homework. I don't know what they were doing, but they had all these pieces of paper all balled up, sitting on the desk, because, well, they couldn't find a trash can, couldn't see the trash can, couldn't be bothered to throw the stuff in the trash, I don't know. On the other side of the table, somebody was using a grinding machine. He was using a right-angle grinder to cut something. Anybody used one of those before? What's the coolest thing about those? You can direct the direction the sparks go. But if you don't know there's a bunch of wadded up paper on the other side of the table, you will light it on fire. So there's good reasons to throw your trash away, besides the fact that it's ugly to leave trash laying around. All right, shine. What do you mean when we say standardize? Somebody besides Evan, Josh, or Ian. In the back. What's your name again? Kate. Yeah, if you've got similar processes or identical processes that happen at several locations, make the workstations identical so that the operator always knows where the tool is, always knows where to put the tool back, always knows where the materials are to do that. You can standardize without being identical also. When you've got similar workspaces, lay them out similarly so that it's obvious, so it's intuitive where that stuff is going to be if you have an operator that's used to using this equipment. The other thing that I think is often overlooked here is if we're going to do this process, we're going to figure it out in a small location. If we try to figure it out by 5S'ing the whole plant, and let's say that the plant is, I don't know, I was at Haas Automation last summer visiting their facility. That's where they make all the machine tools that we use in here. They have 1 million square feet under roof in production. So if we tried to fix all of that at once, we will fail. because just the chunk is too big, right? And no one disagrees. You can't just fix it. So you start in a corner, start in one part of the facility. You get this part figured out, and then you expand out from that corner. It doesn't have to be physically a corner. You could start in the middle and expand out this way or this way. But that will enable you to apply these 5 S's. Anybody, so half of you have been in the lab now, right? But you haven't used any of the machines that we've done this on. So never mind. After next week, you can point out some 5S stuff that you've seen in the lab. All right, so we've talked about 5S. We've talked about the fact that what we currently call lean manufacturing is based loosely, partly, wholly on the Toyota production system. Has anybody know anything about the Toyota production system? Anybody heard anything unique about the Toyota production system? You know, all the car makers use some version of this Toyota production system now. It's not unique to Toyota anymore. Yeah, what's your name? Sam. Yeah, you want it to fit right on the first time. That gets back to the carpenter's adage of measure twice, cut once. Yeah, so in many older facilities, or if we're not applying these principles well, we'll frequently do a process where we keep trying until it works, right? And the best design, and that's really having not designed well also, or make parts that fit because you have this part and then you make this part to fit it. We'll actually do that in ME1800. So when we make the pistons for our thermoacoustic engines, we make each individual person makes their piston based on having measured the cylinder that they made. And so we adjust, and each one of you will adjust the machining process so that you get a piston that fits just right. If we do that, it's not a lean practice for sure. We do that to teach you how to do the process of making the adjustment, as opposed to, because we could actually set up the machine so they always made good parts. That would be boring for you guys because all you do is press the green button and watch the parts come out. So part of the reason we do that exercise is to add value to you. You'll see as we go through the class actually that we tried to use principles of lean manufacturing when we designed the class components. When we designed the lab exercises, we're using these lean principles, applying them to you all, the work pieces. I spent a couple weeks in Virginia, on the Virginia-North Carolina border this summer. So a few y'alls might slip in. So anybody from the South? Anybody would claim they're from the South? Where are you from? Texas? South Carolina? Okay. What's that? Technically? Yeah. I'm from the South. I just don't tell nobody. Dang it. Maryland. Okay. Yeah. All right. So lean manufacturing. So what is the goal of lean manufacturing again? Let's get back to that question, the original question. What's the goal of lean manufacturing? Somebody said, who was it that said increase profit? I forget your name. Julia. I never asked you your name. Oh, but it's on the card. Okay. Julia says increase profit. Now our companies will apply lean manufacturing in order to increase profit. 100%. What's the main focus of lean though? Yep. Oh, we like continuous improvement. That's another lean word. By the way, I like continuous improvement too. So if I suck, tell me. I'll try to get better. Continuous improvement. So what's the focus of lean? So lean is a collection of management tools, right? Would you guys agree to that? Lean manufacturing is a collection of tools that we can use to impact the way our company creates a profit. What are most of those tools focused on? In the back. It's Dionys. Okay, Dionys. Say again. Minimize waste. I'll get rid of the 5 S's. Most of the lean manufacturing tools are dedicated to minimizing waste in manufacturing processes. Why do we minimize waste? Because waste makes cost go up, right? Wasteful things will make cost go up, right? Or it will make time go up, which then makes profit rate go down. So cost going up is bad because profit rate goes down. Time going up is bad because profit rate goes down. Okay, so most lean tools are focused on minimizing waste in manufacturing processes. What is waste in manufacturing processes? Somebody start shouting it out. Non-value added time. Disorganization can lead to non-value added time because we walk around looking for stuff, right? Have you ever walked around looking for something and gotten really mad because you couldn't find it and you had someplace to go? Like your glasses, right? I do this all the time. Where the hell are my glasses? Anybody know where I put my glasses? Right? Car keys, another one. It happened to me this morning. I wanted to go out. I would say for a jog, but look at me. I was going out for a walk. But I wanted to go out for a walk this morning. I got to finish before the kids wake up because I got to help get them ready for school. I'm walking around the house looking for my glasses. At least I got some steps in. I found them. They were right where I put them down last time I had them on my head. Non-value added time. So let's pause on this one because this is an important one. What adds value to the part? And let's think of a part, not a big assembly of something. If we're making a part, what adds value to the part? Yeah. What step adds value? So not what makes a part valuable, but what step in the process? Because manufacturing is applying processes to change raw material into something somebody wants, right? What steps? I mean a generic thing. It doesn't have to be the step that does the transformation from what it was to what they want. So if they want a pipe and we have steel rods, the only step that adds value to that steel rod is the process that removes the material from the center. Does that make sense? I've actually made a pipe out of a steel rod before. Yeah, well, I didn't do it because we had machinists at the place. I was the engineer that requested it. It was at a nuclear power plant. We were shut down. We had gotten permission to replace a valve with a piece of pipe from the NRC so we could start back up. But we didn't have any nuclear safety class pipe in stock. On the other hand, we did have nuclear safety class steel rods in stock that we could drill holes through the middle of, make a piece of pipe out of them, put it in there, and start making money for the company instead of losing money for the company. It's expensive when those things are shut down. So yeah, we've done that. So the only part of that process, the only thing that actually added value was the making the hole, actually cutting the threads on the end in this case too. Added value because the pipe had specifications. Everything else that we did, like get permission from the NRC to do this in the first place, the engineering drawings, setting up the machine tool, rooting around to find this piece of pipe and this piece of steel rod in the steel rod storage area. None of those steps added value to the part, right? Some of them were required. So there's two different kinds of non-value added time. There's and it's muda and something else, right? Anybody remember the words? One of them is muda. I think muda is the waste that is that the waste that you can get rid of, or the waste that you can't get rid of? Somebody Google it later. But one of them is waste that you can get rid of. One of them is waste that you cannot get rid of. So There is waste we can get rid of. Rid of waste, no, TSST, and the other kind. Right, so there's waste, and so what are some examples of waste that we can get rid of? Yeah.
If you're turning a part that has a final outer diameter of like an inch, and you
Yeah.
start with stock that's 2 inches outer diameter, maybe you could just buy stock that's,
So that's absolutely true. So choosing the right stock material for the operation, choosing the stock material that will have the least material removed is waste that we can impact, right? We don't have to, because all the customer cares about is the final diameter, right? So in his example here where we're making a final diameter of 1 inch on our part, if we start with material that's just over 1 inch, we're good. What if we bought material that was 1 inch? Don't have to do, well, depends on the tolerance on the 1 inch, right? Maybe you don't have to do that process. So choosing the right stock material, which I don't think anybody's ever said in class before. It's true though. What else is a waste that we can get rid of? Yeah. He said, for anybody who didn't hear him, he said having to make the same part more than once because you screwed up the first time. My favorite, and we see it a lot in the manufacturing labs here at WPI, is because the part wasn't designed yet when you made it the first time. You see this especially with the PhD students that come in that need the little thing to make their apparatus, to make their thing, and they don't actually know what they want, but they know they need a hole here. So they bring you in the piece of metal and they say, make a hole here. Then they bring it back over to their lab, and then, oh, the hole was the wrong size. They bring it back over. I need a bigger hole. It's easier to make a bigger one than it is to make a smaller one. Smaller one's not impossible. Yeah, so scrap material. Let's call that scrap material. So and you meant making parts that were no good? Yeah. So making scrap or crap. Both terms apply. What else is waste that we can avoid? Yeah.
Would it be like having too many people working on something?
I have noted, and there's a reason that there's 3 PLAs in your lab sections. If I assign 4 PLAs to a lab section, 3 of them will be chatting with each other and 1 of them will be working. When I have 3 PLAs, the workload is such that none of them start chatting and all of them work. So yeah, having too many people could be wasteful. Yeah. Disorganization. Yeah, so walking around looking for stuff, right? Not having done our 5S, our sort and our standardize. Is it time to go? Not quite? Okay. This seems like there's anxious people in the hallway. I will continue talking. I won't stop. So when it becomes time to go, somebody tell me. All right, so what's some other waste? So looking for stuff, right? How about, I gotta put this over here. Okay. I'm gonna put this one here. This one goes over here. And here. Okay, now we're ready to start the process. Moving stuff around. Maybe because the machines that it has to see are not next to each other. If a part needs to go through 3 different machines, wouldn't it be really cool if the stock material arrives here? First machine is here, second machine is here, third machine is here, and the shipping loading dock is over here? That'd be the way to do it, right? That'd be the minimal amount of movement. When I was moving out of that house that had the cool kitchen to a much bigger house that was about a mile away, I had a couple friends helping me, both manufacturing engineers. Now, one of them was a better friend than the other one because he didn't just show up to help. He showed up with a 2-ton trailer and his 18-year-old son, which was especially helpful. And his daughter bought us food, too. She brought us food. But at any rate, at one point, one of them says, you know, we should just build a conveyor between the 2 houses. Does that sound like a good plan? Who likes a conveyor between the 2 houses? Why not? It's automated. It's just automating waste, right? Let's move the 2 houses closer together. That was the right answer. The conveyor would just automate waste. As Bill Gates has a famous quote about this. He said, automating a bad process just help. I can't remember exact words. Google Bill Gates quote on automating waste. You'll find it. He's got a really good quote about this. But let's, we have class tomorrow, right? What are we going to talk about tomorrow? I said at the beginning of class, art part and particularly process variables in machining. So come to class tomorrow ready to talk about process variables in machining. Thank you very much. Yeah, Washburn 229. You need to check the microphone because the box says 323. But I guarantee you we're in 229 tomorrow because this many people can't fit in 323. Yeah.
Over the summer, I worked at a manufacturing company, and one of the big waste they talked about was interruptions.
Oh yeah.
Just basic interruptions.
Bring this up at the beginning of class tomorrow.
Okay.
I've got a great story about that.
Okay. On your one sort of list of what we're doing throughout the week, on Friday it said we had a quiz. So do we have a quiz?
You have a quiz on Friday. It's not in class.
Oh,
we don't have class on Friday. All the quizzes,
Oh.
everything that gets graded will be online,
All right.
except for the lab practical, which